2021 was already a stellar year for SpaceX, but there's no stopping the company nor its eccentric CEO from reaching new heights this year. Always full of ideas, their billionaire CEO Elon Musk wants SpaceX to reach Mars using carbon capture. And according to various resources, this is a plausible idea and how it could work. If you're curious to know what the company planned, then keep on watching to know more. Elon Musk wants to use carbon capture as rocket fuel for Mars project and urges companies to take part. The richest man on the planet is never short of ideas on him being dead set on the Mars mission. He's been pushing on decreasing the concentration of carbon dioxide in the atmosphere, which he took to his Twitter account. SpaceX is starting a program to take CO2 out of the atmosphere and turn it into rocket fuel. Musk wrote in a tweet, "Please join if interested." So far, no solid ideas or plans have been made on how the tech billionaire intends to do this, but the idea itself is pretty appealing to many, considering the abundance of CO2 in the atmosphere. Can you imagine how life here could be so much better with lesser CO2 populants? What's more, harnessing these into rocket fuel and other resources would greatly improve our quality of life. As if to emphasize a point, Musk also replied to his previous tweet saying, using CO2 as rocket fuel will also be important for Mars, which gave the public and his followers high hopes for the future. Ironically speaking, Musk and his company continue to contribute to the CO2 emission on our planet, but he seems to be well aware of that, which is why he announced earlier in 2021 via Twitter a $100 million prize for the best carbon capture technology as an effort to join the ranks of governments, organizations, and leaders whose mission is to slow the hastening of climate change. I am donating $100 million towards a prize for best carbon capture technology, the billionaire wrote back on January 22, 2021, and followed it up with details next week. The $100 million X Prize carbon removal was named as the largest incentive prize in history and will last for 4 years through Earth Day 2025, according to organizers. What is direct air capture and how will it help the environment? Way before Musk announced his $1 million prize for the best, several companies and groups were already practicing carbon capture and storage, and as of the moment, there are 19 direct air capture (DAC) plants in operation worldwide. In simpler terms, DAC technology uses giant fans to draw in the air with the CO2, roughly 0.04% of the content of air, bonding to chemicals known as sorbents. When these sorbents become saturated, it is heated to 80 to 100 degrees Celsius to release the captured CO2. Futurism also published a report that DAC plants suck 4,400 tons of CO2 annually, and another DAC plant will begin operations in Scotland by 2026, whose goal is to remove 1.1 million tons, 1 million metric tons, per year. More and more organizations and companies are taking an interest in carbon capture and storage, which have been the leading cause of the warming climate we're experiencing right now that's making the glaciers melt and intensifying tropical storms. Scientists and experts said that carbon removal technology will play an important role in obtaining zero emissions by 2050. Unfortunately, these types of technologies are not only expensive, but it's also not yet commercially viable. As it stands, removing carbon can cost more than $300 per metric ton, and experts estimate that we may need approximately 10 billion tons of carbon capture by 2050. I think this is one of those things that is going to take a while to figure out what the right solution is, Musk said, and especially to figure out what the best economics are for CO2 removal. Elon Musk's $100 million X Prize carbon removal's goal is to find a viable solution that will take 1,000 tons out of the atmosphere annually with the potential to scale up drastically. Those who wish to participate in the event must have a plan to conceal carbon for at least 100 years. Many Silicon Valley startups showed interest in the competition. PitchBook even reported that $336.5 million were raised by venture capitalist-backed carbon removal companies back in 2020 as an effort to join the cause. Defining carbon capture. How can we utilize it and maximize its effects? Carbon capture utilization and storage, CCUS, is defined as the idea of capturing carbon dioxide, CO2, emissions before they can escape into the atmosphere. From this, technologies are made to filter carbon dioxide dioxide from climate-harming sources like coal-fired power plants. The carbon extracted will then either be used or stored elsewhere, since it can't escape, rise, and mix up with the atmosphere. Companies are joining the carbon capture movement and choosing environmental sustainability. Many companies, such as PepsiCo and Chevron, are already investing in new carbon capture technologies, with PepsiCo even announcing their plans to reach 100% renewable energy for all US-based operations back in 2020. The same year, Apple also announced plans to make all of its products 100% carbon neutral by 2030. Businesses have a profound opportunity to help build a more sustainable future, one born of our common concern for the planet we share, Apple CEO Tim Cook said in a statement. He continued, "The innovations powering our environmental journey are not only good for the planet, they've helped us make products more energy efficient and bring new sources of clean energy online around the world. Climate action can be the foundation for a new era of innovative potential, job creation, and durable economic growth. With our commitment to carbon neutrality, we hope to be a ripple in the pond that creates a much larger change." As exciting as this news sounds, companies need to find more technologies that could turn the global energy infrastructure crisis we're all facing. Japan, as one of the leading and technologically advanced countries in the world, is already on it, and they have managed to create a new material capable of capturing CO2 molecules and turning them into less harmful organic materials with minimal energy. A collaboration between the scientists from the University of Tokyo and Yangtze Normal University in China, the material was first published in the journal Nature Communications back in September 2019. "We have successfully designed a porous material which has a high affinity towards CO2 molecules and can quickly and effectively convert it into useful organic materials," said Kyoto University's Kenichi Otaki, a materials chemist, in a press release at the time. The material they created is a porous coordination polymer that is made up of zinc metal ions and can selectively capture carbon dioxide molecules with an efficiency that is 10 times better than other porous coordination polymers, or PCPs. But that's not all there is to it. The PCP can also be reused up to 10 reaction cycles, and once the CO2 is captured in the material, it converts it, in which it can be used to create polyurethane, a material frequently used in making applications, packaging, and even clothing. Students from Tasmania University won $250,000 for invention of seaweed-based carbon capture. Although a lot of startups and well-established companies are answering Elon Musk's call for carbon capture, there is an impressive group of students who are also joining the cause and were even awarded for their efforts. For one, Blue Symbiosis from Tasmania University have joined the cause. The group aims to use seaweed as their base material. Since seaweed also has carbon dioxide absorbing properties and are known to remove carbon from the atmosphere that help restore oceans, in addition to that, they also aim to use these stored carbon as construction materials by making them into fire-resilient bricks. The project sets its eyes on the unused oil and gas rigs as farming sites, to also help address a problem that is totaling up to $44 billion for decommissioning the infrastructures. Another group of students who were awarded came from University of Oxford and is also known as cyanocapture. Their group makes use of a genetically modified bacteria called cyanobacteria to capture carbon for the long term. Cyanobacteria is expected to capture up to 3 times more carbon compared to normal bacteria. These two groups are part of the 23 projects that were awarded $5 million out of the total $100 million prize money, wherein 5 of them were granted $100,000 each on their measurement, reporting, and verification technologies. As for the 18 other teams, they were awarded $250,000 for their demonstrations of carbon removal to develop their projects and technologies and increase their competitive abilities in the next round of the competition. France built the world's first ever carbon negative building. Although most of the public's attention is focused on Elon Musk, France already built the world's first ever carbon negative building, and it's made of hemp. Located in the town of Croissy-Beaubourg, the structure is called Pierre Chevette Sports Hall and boasts a 4,000 square foot, 380 square meters, building space, which includes an exercise hall and changing rooms. Hempcrete, the key material for the sports hall, is a mixture of hemp with lime and water that makes it a carbon-negative building. Hempcrete weighs 1/8 of regular concrete and has thermal and acoustic properties, as well as being fire-resistant. Interestinginengineering.com said of the material, "Hemp can grow up to 13 feet or 4 meters and can be cultivated in 90 to 100 days. It is lighter and less expensive than wood and can grow 100 times faster than an oak tree." There are a lot of other innovations we'd love to discuss more, but unfortunately we're out of time. Which ones did you like best? Share with us in the comments below. Thanks for watching today's video, and don't forget to hit the like and subscribe button with the notification bell on before you go. See you next time you go.